So in this next unit, we're going to be solving systems of equations, and systems of two equations and two variables means that, when you have one equation, you have a set of points that are on that line. And when you have another equation, you have a set of points that are on that line. And then if you have a system of equations, you're trying to find the one point that they have in common. So that would just be the point where they cross. Sometimes you can do it graphically, but sometimes you have to do it algebraically. Solving by graphing is not that bad. There are two sets of directions. This is the one for Desmos, and then this is the one for using the TI calculator. Desmos is definitely easier. I'm so glad you're here, Maya. Grab a calculator and take your computer out. Okay, so input the equations in Desmos, find where they intersect. This is quite easy. I want you to do that. I'm going to open a new Desmos because that one had some old stuff in it. That's the first one, and then that's the second one, and then what I want you to do is click the point where they intersect and write the solution. And then we're going to have to do this on our TI calculator. So I'm going to click this point. I get 2.6 comma 3.8, and I'm going to write that in the box as my solution. 2.6 comma 3.8. But sometimes we'll do these problems on the calculator instead of on Desmos, and it's a little bit harder, and here's why. When we graph on the calculator, you have to graph in the y equals. So up here you would press y equals. And so notice you can only graph equations that start with y equals. So the y equals button is up here on the top left, but you can only graph equations that start with y equals. So looking at our equations, one of them is all set, the other one is not. So here's what I'm going to do. I'm going to take this equation, 3x minus y equals 4, and I'm going to solve it for y. So I'm going to subtract the 3x from both sides. And I have negative y equals 4 minus 3x. And then I'm going to divide both sides by negative 1. And that's going to give me y equals negative 4. Negative and negative will cancel here, so that will be plus 3x. So in the Desmos calculator, I'm going to graph this one and this one. Yes. All right, so the first one says negative 2. The X button is next to the green button. Plus 9. And then the second equation is negative 4 plus 3x. Raise your hand if you need help finding those buttons. After that, you should be able to just press graph, but some of my other students have really weird windows going on. So what I'm going to suggest we do is we hit zoom and go to standard. That will give us the standard window, not the ones that my other students kind of messed up. And you can see that they crossed there. Would you like to hear that again? Yeah. Okay, so after you put the two equations in y equals, then go over 2 buttons to zoom. Hit the zoom, and standard is the 6th choice, so you can hit 6 to get the standard window. And it should look like this.
So what do I press? I have to press graph.
So to find the point where they cross, we have to calculate it. Notice calc is above the trace button. So press second, and then press the trace button, because calculate is above it. we want to know where the lines intersect. So you choose 5, and then you're going to press enter 3 times. 1, 2, 3, and it gives you the same point that we found on Desmos. All right, then you are going to replace the x in the other equation with what x equals, the 2 minus 2y. So I'm going to rewrite my first equation, starting with the 3. Instead of the x, I put what the x equals, 2 minus 2y. And then I continue writing the rest of the equation, plus 4y equals negative 4. So I took one equation and I got a variable by itself. I took what the x equals, and in the other equation, I replaced the x with what the x equals. The advantage here is that now my equation only has y's in it. It doesn't have x's and y's. And so now I can solve for y. Okay? So that's what I'm going to do. I'm going to distribute, combine like terms, and solve for y. So we'll distribute the 3 first. 6 minus 6y plus 4y equals negative 4. I'll combine these two like terms, so I get 6 minus 2y equals negative 4. To get the y by itself, I have to get rid of this positive 6, so I subtract it. And now I have negative 2 times y. To undo times y, I will divide by negative 2. To undo times negative 2, I divide by negative 2. And I get y equals 5. And that was a lot of work, but I'm actually not completely done yet. I'm going to pause for a sec, though. All right, so I'm trying to find the point where they intersect. Did I find the whole point? No. What do I have to still find? The x, right. That's not that hard, though, because I already have x by itself here, so I'm just going to substitute the y, the 5 for the y. So x is equal to 2 minus 2, and then instead of y, I'll put in 5, like that. Order of operations says multiply before you subtract, so I have 2 minus 10, which is negative 8. So now I have the x and the y. I'm going to express my answer as a point where the x comes first. So in elimination, we're trying to eliminate a variable so that we can solve. Remember, we can't solve when x and y are in the same equation. So if we eliminate a variable, we can. Sometimes you can add the two equations together, and you might have a positive y and a negative y. They would cancel out, and you could that variable would be eliminated. But sometimes you have to do a little work on these equations before you can do that. So in this case, I could either make the x's match up or be opposites, or I could do that with the y's. Is it going to be easier to make the same x's or the same y's? The same coefficient or opposite coefficients. Wait. All right, the y's are going to be easier because I could multiply this y by 2, and then it would become the opposite of negative 2, okay? But I'm not allowed to just do that unless I keep my equation balanced. So if I want to multiply this side by 2, I have to also multiply this side by 2. So you can multiply an equation by 2 as long as you multiply both sides to keep it balanced. So what I'm going to do is I'm going to bring this equation down here now. 2 times 2x is 4x. And 2 times y is plus 2y. And then 1 times 2 is 2. So the reason I multiplied both sides by 2 is because I wanted my y's to cancel out. And they weren't going to cancel out when I just had a 1y there. So now, if I add these two equations together, the y's will cancel. I'll add my x's and get 9x. My y's will cancel. And then I add negative 10 and 2 and I get negative 8. And so it looks like my x is going to be a fraction this time. I get x equals negative 8 over 9. Which isn't so easy for substituting back in, but we'll deal. I think what I'm going to substitute back into is the first equation that was original, 2x plus y equals 1, just because it seems like the simplest one. You can choose any of them, though. And I'm going to put the negative 8 over 9 here, so I have 2 times negative 8 over 9 plus y equals 1. When I multiply, I can make this into a fraction and multiply numerators and denominators. So I have negative 16 over 9 plus y equals 1. And then to get rid of this, I will add it, and then I'm going to turn to Desmos so I don't have to add a fraction. Can anybody add that in their head? 1 plus 16 over 9?
No.
You remember you need a common denominator. I'm not going to make you do it right now, but let's see what it gets. 1 plus 16 over 9, and then making it a fraction, it's 25 over 9. Anybody have that? Because remember, the number 1 is 9/9. So you have 9/9 plus 16/9. And that gets you 25/9. Okay, where is my paper? Here it is. So y is 25/9. Negative 8/9, comma, 25/9. Really, both methods are good for the first one. A lot of you guys did substitution, and that's what he was asking about, so I'm going to do that right now. But if you did elimination, I can show you that as well. So for substitution, you want to get a variable by itself, and most of you chose to get this y by itself. So you would subtract the 2x like that, and get negative y equals 9 minus 2x, and then divide by negative 1. And get y equals negative 9 plus 2x. And then you would substitute this for y in the first equation. So bringing my first equation down, I would have 3x plus 2. Don't put the y, instead you put what y equals, negative 9 plus 2x, and then equals 10. So then it's just a little bit of manipulation. I know that a lot of you know shortcuts on Desmos for solving equations, but A, you may not have Desmos for a quiz, and B, some of the points assigned on your tests are going to be for your method, so you need to actually know the steps. So write them down if you didn't get them yet. So we're going to next distribute the 2. So we have 3x minus 18 plus 4x equals 10. Combining like terms, I get 7x minus 18 equals 10. And then add 18 to both sides. And now I have 7x equals 28. And dividing by 7, I get x equals 4. I'm going to pause there for a minute, but remember, oh, you didn't see all that. Remember that we're not done. So I got 7x equals 28, and then x equals 4. And now I have to find what? Y. So you could put it in the first equation, you could put it in the second equation. The easiest place to put it is in this equation that has y by itself. It will work in all of them, but this one's the easiest for me. So I'm gonna write that equation just as a reminder of what I'm using. And now I'm gonna replace the x with 4. So order of operations says 2 times 4 is 8, then plus negative 9 is negative 1. So that should be negative 1. Did anybody check this with Desmos yet? Is it 4 negative 1? Yeah? Okay. What other questions are there on 1? Does anybody want to see that problem worked the other way with elimination? Okay. Because I also think that substitution could be a good way to do too. I know some of you did it with elimination, and that's also fine. But here's how substitution works. You already have variables by themselves. So if I know y equals x plus 2, I can take that x plus 2 and substitute it for y in the other equation. So instead of starting with y equals, start with x plus 2 equals. And then you can put the 3x minus 4. And then we just have to solve by getting your x's to one side. So you could subtract x like that. 2 equals 2x minus 4, and then get the x by itself. I'm going to add 4. And then divide by 2. So x equals 3. And then substitute that 3 back in to find your y. So y equals x plus 2. I'll put the 3 for the x. And I get y equals 5. And then you write the point. I'm going to pause there for a minute because I want to know what you are more interested in seeing next. We could do a word problem together, or we could do a problem that uses elimination. You want to see the elimination in number 4? Yeah, number 4 is going to be a tricky one, but I do agree that elimination is the best strategy. Let's look at number 4 together. So in number 4, there's no number I can multiply negative 6 by to get negative 9, and no number I can multiply 4 by to get 5. And so what happens is I have to multiply both equations. You can actually multiply them both by their same coefficient. So for example, I'll multiply, do you guys want to eliminate the x or the y? Which one? The x? Okay. So if we want to eliminate the x, multiply the first equation by the coefficient of the second equation, which is negative 6. And then multiply the second equation by the coefficient of x in the first equation, which is 9. All right, so now my first equation will become negative 54x. Negative times negative is positive 30y. And then negative times negative is positive 42. So I multiplied the first equation by the coefficient of x from the second, and now I'm going to multiply the second equation by the coefficient of x in the first. So this is going to become negative 54. Oh, is it negative? Oh, it is. It's the same. I could have multiplied, I could have multiplied the first one by positive, so they'd be opposites, but we'll figure this out. And then this is going to be 36y, and this is 18. All right, so adding them together won't cancel it out because that's going to give me negative 108x, but I can subtract them. So if I subtract these, that will cancel. And then I subtract these, I get negative 6y. And if I subtract these, I get 24. All right, then divide. And y equals negative 4. And then I have to put this back in an equation. You can use one of these equations if you want, but the original ones look nicer. So it doesn't matter which one you take. I'll take the first one. 9x minus 5y equals negative 7, and put my number for the y. So I'm getting negative 3, negative 4. Has anybody graphed it yet to see if that's the right answer? It is? Okay. Plain problem and see how far we get, and then we'll bring our notes back to finish next class, okay? All right, so Caroline has $21.40 in dimes and quarters. So we can say that x is equal to the number of dimes, and y is equal to the number of quarters. We have to define the variables so that we use them properly. So if I added x plus y, the number of dimes plus the number of quarters, that would give me how many coins altogether? Looking at the information. 100 coins altogether. And then I can make a second equation about the money. So, and what number would I put in front of the x? Right, so 10 cents would be 0.10 x plus, what in front of the y? 0.25. Very good. So 0.10x plus 0.25y is going to give us the total money, $21.40. So setting it up is the hard part. Oh, I can't see. Sorry about that. Once you set it up, you just need to do the same thing as before. You could use substitution or elimination. Does anybody have a suggestion? Would you like to use substitution or elimination? I heard substitution, okay. So what I'm going to do is subtract x from both sides of this equation and get y equals 100 minus x. And then I can substitute that for the y in the second equation. Okay, so 25 cents, and then I'm going to put in the 100 minus x. And now you are excused. Okay, sorry. We'll finish this problem next time. All right, so then we can distribute.
There, he's right there. I just found your name.
And then I subtracted these, and so I get negative 0.15x plus 25 equals 2140. And then I'll subtract the 25. And I get, oh, I'm running out of space. Negative 0.15x equals negative $3.60. And then I'll divide the negative 0.15. I think I need to turn to a calculator finally. And hopefully this comes out right. All right, so I get negative $3.60 divided by negative 15 cents equals 24. So I get 24 dimes, and if I subtract that from 100, the rest should be quarters. So 100 minus 24 should give me 76 quarters. And so I can express my answer as a point, 24 dimes, comma, 76 quarters. Oops. Okay. All right. Next problem is definitely set up for elimination. You can see how the x's are lined up, the y's are lined up. In this one, I'm going to multiply the first equation by -2 so that I can get the opposite of +2. And I can just add the two equations together. So when I bring this down, I get -2x plus 4y equals -10. So my x's cancel out, but my y's also cancel out, so I get 0 equals -3. So 0 does not equal -3. Those are totally different numbers. And so that means that no matter what I put in for x and y, I'm going to get 0 equals -3, which is not true. So there are no solutions to this problem. And if I were to graph this, what I would get is a set of parallel lines which would never cross each other, and that would indicate also that there were no solutions. Okay, the last one is set up for substitution. So I have y is equal to 3x plus 2, and I will replace the y with 3x plus 2. So I have 6x minus 2, and instead of the y, I'll put the 3x plus 2 equals -4. And then I'll distribute this is a -2 that I'm distributing. Bring down the 6x. -2 times 3x is -6x. -2 times 2 is -4 and equals -4. So 6x minus 6x cancels. I get -4 equals -4. Now this is true. -4 equals -4, and that means that whatever x I put in to my equation, I'll be able to find a corresponding y that will make this equation work. And so this has many solutions. It's basically the same line. One line would land right on top of the other. They would share all their points. So not every point in the whole coordinate plane is a solution, but every point on that line is a solution. And so it has infinitely many solutions.